Hello guys, welcome to this episode of my tutorial video series. Today I shall solve an inclusive problem on production function. That is a mathematical problem and solution on production function. Now this is part 1. In part 1 I am going to solve one very inclusive problem on production function. So let's get into it. We have to find out the relationship between Apl and Mpl, that is average productivity of L and marginal productivity of L. Now when we are talking about Apl and Mpl, it is obvious that it is a short run production function, and the production function is given by Q is equal to F, K and L. That is, there are two inputs, capital and labor, and in the short run K is held constant, say at K0. So in short run the production function becomes, in short run the production function becomes Q equals to F K0 L. K0 is constant capital. So the form is using two inputs, labor and capital, and in the short run K is held fixed at K0. So in the short run the production function becomes Q equals to F K0 L. So we have to show the relationship between average productivity of labor and marginal productivity of labor. In the short run, what happens? All the factors cannot be changed. So one factor is changed, that is increased, and other factor or factors remain constant. So in this case the firm is using two inputs, capital and labor, and in the short run capital is held constant at K0 and the firm is increasing the amount of labor, so that we can find out Apl and Mpl. Okay. So what is average productivity of labor? Apl is equal to Q by L. Q is quantity of output and L is labor. So Apl, that is average productivity of labor, is Q by L. Now DDL Apl is equal to DDL Q by L. We are differentiating average productivity of labor with respect to labor. So DDL Apl equals to DDL QL. This means this is equal to L dQ dL Q minus Q dQ dL L divided by L square, right? We are differentiating Apl, that is Q by L with respect to L. So DDL of Q by L becomes L dQ dL Q minus Q dQ dL L divided by L square. So this is L dQ dL minus Q into 1, dQ dL of L is 1 divided by L square. So this becomes L dq dl divided by L square minus Q by L square. This becomes 1 by L dq dl minus Q by L square. Now we take 1 by L common. So this becomes 1 by L dq dl minus Q by L, right? So we have differentiated APL with respect to APL, that is Q by L, with respect to L, and we have got what? We have got DDL of APL is equal to 1 by L dq dl minus Q by L, right? So this is 1 by L dq dl means MPL, that is marginal productivity of labor, and Q by L is APL, that is average productivity of labor. Now listen carefully. APL will increase or will remain constant or will decrease depending upon the value of this, right? So we can say APL is increasing if this is greater than 0, 1 by L into MPL minus APL is greater than 0, only then APL will be rising. This means MPL is greater than APL. So when APL is rising, MPL is greater than APL. Okay. So here only we have differentiated APL with respect to Q by L, and we have found out DDL of APL is equal to 1 by L multiplied by within bracket MPL minus APL. So whether the APL will increase or will remain constant or will decrease depend upon the value of this, that is the value of DDL APL. If this is greater than 0, then APL is increasing, and if this is greater than 0, then MPL is greater than APL. Okay. Next, APL is constant if 1 by L multiplied by within bracket MPL minus APL equals to 0. This means if this becomes equals to 0, then MPL is equal to APL, and here APL is maximum. Here APL is maximum, where MPL is equal to APL. APL is maximum. Next, APL is decreasing or falling if 1 by L multiplied by within bracket MPL minus APL is less than 0. Right? APL will be decreasing if DDL Q by L, that is 1 by L multiplied by within bracket MPL minus APL is less than 0. This means if this happens, That is, if 1 by L into MPL minus APL is less than 0, it denotes MPL is less than APL. That is, marginal productivity of labor is less than average productivity of labor. Now, if we draw the diagram, we can check. Same thing is happening. We can show through a diagram. On x-axis we measure quantity, and on y-axis we measure TP, that is total product, APL and MPL. Total product, average productivity of labor, and marginal productivity of labor. This will be the TP curve, and TP is maximum at this point. Say this is point M. Okay? When TP is maximum, MP becomes 0. So this is MPL, right? And the APL curve is like that, like this, as I am drawing. This is APL. Now see, when MPL is greater than APL, here MPL lies above APL. APL is rising, APL is increasing when MPL is greater than APL. Okay? Next, APL is constant if 1 by L into MPL minus APL equals to 0. That is where MPL equals to APL. Here you see MPL is equal to APL, and APL is maximum at this point. At this point APL is maximum, and MPL becomes exactly equal to APL. Next, APL is decreasing if this is less than 0. That is, if 1 by L multiplied by the bracket MPL minus APL is less than 0, that is, if MPL is less than APL. Here you see, beyond this point, beyond the maximum point of APL, MPL lies below APL. That is, MPL is less than APL. Correct? So, these are the relationships between marginal productivity of labor and average productivity of labor. We have taken the production function as Q equals to F, K and L. K is capital and L is labor. K is capital, L is labor. Now in short run, amount of labor is changed, that is, amount of labor is increased while amount of capital is held fixed. So we have assumed that K is held fixed at K0 in the short run. So the production function becomes Q equals to F K0L. APL, that is average productivity of labor, is equal to Q by L. Now we are differentiating APL, that is, we are differentiating Q by L with respect to what? With respect to L, because K is held constant. So DDL of APL equals to DDL of Q by L. DDL of APL is equal to DDL of Q by L. This is average productivity of labor. This is equal to L dQ dL Q minus Q dQ dL L divided by L square. Yeah, I am using calculus because calculus is the only way to solve this kind of problems. So you have to be used to with calculus. Still, if you have any problem in understanding calculus, you may please let me know. Okay. So L dq dl q minus q dq dl L by L square is equal to L dq dl q means dq dl minus q dq dl L, that is minus q into 1. Dq dl of L is 1 divided by L square. So this is L dq dl by L square minus q divided by L square, that is 1 by L dq dl minus q by L square. So this ultimately becomes 1 by L multiplied by within bracket MPL minus APL, that is 1 by L into within bracket marginal productivity of labor minus average productivity of labor. Now APL increases or remains constant or decreases depending upon the value of this. If APL increases, then this will be greater than 0. So in that case MPL will be greater than APL. Here you see MPL is greater than APL because MPL curve lies above APL curve, and in this section APL is increasing. So APL increases when MPL is greater than APL. Next is APL is constant if 1 by L multiplied by within bracket MPL minus APL equals to 0. This means MPL minus APL equals to 0 because 1 by L is not 0. Therefore MPL is equal to APL. Here APL is maximum, that is where when marginal productivity of labor becomes equal to average productivity of labor, at that point APL, that is average productivity of labor, is maximum. Next, APL is decreasing if this is, that is 1 by L into within bracket MPL minus APL is less than 0. That is when MPL is less than APL. Look at here. When APL is falling, because at this point APL has reached its maximum, beyond this point APL is falling and MPL lies below APL. That means MPL is less than APL. Correct? So this is all about the relationship between MPL and APL. I hope it is well understood by you. Still, if you have any doubt in your mind, if you need further clarification on any point, you may feel comfortable to let me know. I shall be more than glad to respond to all the relevant queries, doubts, etc. And if you think this video is going to benefit you or it has already benefited you, then please do share this video with your friends so that they can also get benefit by watching this video. And finally, thank you for watching this video. Goodbye and stay well.